So welcome, good afternoon, everyone. Thank you for being here today on our Science Talk event of the Permanent Forum of Binational Waters. March 10th, 2022. We're happy to have you here, and we are even more happy to be co-hosting this event with the University of Texas, El Paso, with the swim team, which I'm going to introduce in a bit. But before that, just quick instructions to all of you on the interpretation, on the language translation. Please make sure you select the interpretation icon on the bottom of your screen, select the language that you want to hear, and make sure you also select mute the original audio. So you have both languages available to you. And with that, it's already 4:07, so I'm going to be quickly introducing our speakers, well, our hosts today of the Science Talks. And I'm going to start with the title of today. What are we going to talk about today? Sustainable water through integrated modeling. SWIM, that's the acronym for sustainable water through integrated modeling. A platform for exploring water futures with a binational perspective. So we thank you, SWIM team, for being here today. And I'm going to start introducing them pretty quickly so they can take over and do everything that they have planned to do with us today. First, I'm going to introduce Natalia Villanueva Rosales. Dr. Villanueva Rosales, she's Associate Professor of Computer Science at the University of Texas, El Paso. Her research aims to improve the automated discovery, integration, and trust of scientific data and models. Her approach links human and machine knowledge to address societally relevant problems in areas that require interdisciplinary approaches supported by data science. Her work has been applied in areas of sustainability of water resources and smart cities. She's the PI of the NSF-funded SWIM to a Sustainable Water Future project that provides a human technology framework to advance water sustainability research capabilities. Next, I'm going to introduce to Joe Heyman. He is the director of the Center for Inter-American and Water Studies, professor of sociology and anthropology at UTEP as well. His research interests include all things that concern borders, that's a lot, and the processes that shape them and pass through them. In recent years, he has worked on transboundary water issues, first as a co-PI of the USDA project, Sustainable Water Resources for Integrated Agriculture in a desert river basin facing climate change and urban growth, from characterization to solutions. Then as a co-PI of the NSF project Elements Data HDR SWIM to a Sustainable Water Future. In the work with SWIM, he has focused on investigating and implementing how to make the computer interface decisions about inputs and kinds of outputs more relevant and interesting to participating users from varied backgrounds. He's now starting a new NSF initiative to research and characterize a wide variety of water issues along the US-Mexico border using existing work and participatory input. I'm gonna leave it that right there because it's complicated the rest of the of the biography. Next, we have Dr. Diana Pennington. She's Associate Dean of the College of Science, Professor of the Department of Earth, Environmental and Resource Science in the University of Texas, as well at El Paso. She's a physical geographer with cross-training in learning sciences. Her research focuses on how changes in climate and land structure impact surface processes such as water, wildfire, and biodiversity, especially focused on modeling approaches to analyzing and projecting trajectories of land change and socio-environmental systems. She also has a line of research and knowledge integration across disciplines, focused on reasoning with data and models as a mechanism for facilitating social learning about complex socio-environmental systems. Most of her work is at the boundaries between socio-environmental science, interdisciplinary teamwork, and emerging technologies. Next, please, Gabi. Luis Garnica Chavira. He's a research associate on in the Cyber Share Center of Excellence at UTEP as well. He's a computer hardware and software engineer. His research focuses on the application of the software engineering lifecycle and agile approaches to develop cyber infrastructure that supports the advancement of scientific research. His area of expertise includes the creation of software solutions for data to model and model to model integration with the use of web-based and novel data management technology. Luis currently leads the SWIM IT sub-project. His work involved close collaboration with interdisciplinary research teams, comprised of experts in the fields of computer science, civil engineering, environmental engineering, hydrology, and anthropology. Next on the SWIM team, we have Catalina Salas. She's a PhD student in environmental science and engineering at UTEP as well. She's a PhD candidate in the environmental science and engineering program. Her research focuses on how people understand, communicate, and reason about future scenarios of food and water availability using scientific data and models. Her study questions focus on data and model reasoning competencies, including understanding, knowledge, systems thinking, strategic thinking, futures thinking. God, there's a lot of thinking here. Collaboration skills, data skills, and values thinking. Someday we need to talk with you, Catalina, because this is really deep. The mechanisms that she uses to investigate the presentation of scientific data and models includes static graphs, canned models, interactive models, and conceptual models. The findings derived from her research will prove useful to improving our understanding on how non-scientists engage with scientific models and data. And that's extremely important these days. And that's why we have this event here. So with that, I'm going to stop talking. I'm going to leave the floor to you guys. If you want to take over and start your presentation, the floor is yours.
Hello to everybody here. We're going to give you a brief introduction to the SWIM project and the overall framework, but quickly get into something that's hands-on and engages your active learning. We've already described what SWIM stands for. Next slide. So this is the team. The team's been introduced. There's a couple of other graduate students from computer science, Angel Ortega and Alex Vargas. And I also want to give a special acknowledgement to some of the people who have worked on the components that have been put onto the SWIM computer platform. Alfredo Granados, who's here at the event from UACJ, who's had an important role in modeling the hydrology. Dave Gutzler, University of New Mexico, who worked on the climate models. Shuping Sheng, who worked on hydrology also. Bill Hargrove, who was the PI of the antecedent USDA project. And so really made everything that's here possible. Alex Mayer, who's at UTEP in civil and environmental engineering, who did the water quantity modeling, and Frank Ward, who's in agricultural economics at New Mexico State, who did the hydroeconomic modeling. So thanks to it's a large and diverse team that put this thing together. Next. So the reasons we did SWIM is that there's a challenge of engaging stakeholders. We can do all of this modeling and gather all of this data, but how do we give people something that they can understand, that they can work with, they can engage with? And so SWIM is a platform that enables that. Participatory modeling. This is, we can do the sophisticated things that I just mentioned, the hydroeconomic model, the water quantity model, but they're, it's really sort of relegated only to scientists. And we are trying to find a way to make it more open and more participatory in the border environment, which, and we'll mention this again, but which means, having it in the different units of the two countries, metric and English units, having it in English and Spanish, having, an inclusive approach to many different kinds of water. Scientific tools oftentimes require steep learning curves, coding skills, they may have limited documentation. And so there's a lot of barriers to using scientific tools, and we wanted to make these things more accessible. Where we have these items in a unified interactive platform, and this is a response to the challenge of interoperability. Diverse data that was generated for different purposes from sources that are scattered, you know, that not the least in the two separate countries. And how to put something together that enables you all to be able to use that. And finally, relevant models. The models are, you know, fragmented into a lot of different skill sets and a lot of different areas that haven't been designed for integration. And so we have to figure out how to make it possible to integrate them and make it possible for people to be able to use them, for example, on their computer, their desktop or laptop computer. Next. I think Natalia will talk about the swim project itself.
Thank you, Joe. Good afternoon. Buenas tardes a todos. So as you mentioned, SWIM is a really human technology framework. It's not just a tool, but we have done a lot of research on engagement of stakeholders to support how we generate and understand and do interpretation of the results of water-related models. And there's been a lot of efforts on that part. So the development of SWIM, or the components of SWIM, they follow a three-pronged approach. SWIM semantics, or SWIM-SEM, focuses on the use of data about data, or semantics. What do we know about the data to enhance and automate a lot of tasks for the users to execute and understand data models? And this is one of the technical components that we can see there. You will see things as knowledge graphs, as Joe mentioned. We do have different units, we have data across. We also have SWIM participatory modeling, or PM, that enables participatory analysis. And I know Diana, and during the project, this demo will talk more about this. The socio-environmental water systems, which, as you know, it's very complicated, but we're using data and model-based reasoning and a strong stakeholder engagement since the beginning, since day one, for conceiving and testing this framework that we have created, even, you know, leveraging the work of this previous USDA funded group that helped us with the modeling. And finally, we have the IT, which uses all the things that we can now use for recommenders for making this tool useful, not only easy to use, but useful for you, reusable and sustainable. So these three areas were integrated in an interdisciplinary effort, as you can see, that we did here at UTEP and our collaborators to support sustainability and water sustainability research capabilities, to be more specific. So currently you have, and you will today work with an interface that is web-based to access water-related models with metric and English units that with data that was collected across the border in Mexico and the US. And again, thanks for our collaborators. The graphical interface is web-based, so you don't need to install anything else. It's publicly available. Anyone can use it. And in addition, for those who are interested in accessing the data or the models or other services that we have in SWIM programmatically, we have something that we call in computer science API, so people can program and get the information. And we've done a lot of efforts on documenting all the services that we have so other people can use it as well. So a distinctive characteristic of SWIM that you will also be able to do and see today in this tutorial is that we use a recommender system, just like the ones that are used to recommend things to shop or things to see in other applications, to show users, in this case, or anyone interacting with the tool, relevant model outputs, right? These outputs are complex. These outputs are maybe overwhelming, a lot of results. So based on the role and other people using the system, you can get a recommendation of how to start looking at SWIM and then get familiar with the models, right? We will again further explain these features in our demo. And now I will pass the microphone to Diana Pennington. She will talk about the coverage and other key components and tasks that can be done with SWIM.
Hello, everyone. As Joe and Natalia have already mentioned, this is a web-based interface to multiple scientific models. Right now, we only have 2 models that are linked to it, but there could be any number of models. And it isn't limited just to this region. You could run the same thing in other regions, but there would be a lot of work involved putting the data together to do that. So we have 2 models. They both run over the area that you can see on the map to the left. The study area starts north of Elephant Butte Reservoir at the San Marcial stream flow gauge, and it runs all the way down to Fort Quitman, where essentially the stream flow is absent. Within that study area, the 2 models we have right now are both considered what we would call bucket models. So they're not spatially explicit in the sense of a GIS layer. What they are is that we consider the reservoir a bucket, we consider both of the aquifers buckets, and then the river is what we think of as a leaky pipe that runs between those. So within that, both of the models model all of the hydrologic processes that you could think about. It starts with inflow at San Marcial. That is actually calculated by our collaborator, Dave Gutzler at University of New Mexico, based on precipitation in the headwaters in Colorado. And he and his student did a ton of work statistically figuring out how to go from precipitation in the headwaters to inflow at Elephant Butte Reservoir. So everything starts with that driver. Those models, the precipitation models, use climate model data from a variety of different climate models around the world using different emissions scenarios. So as I recall, they used 12 different models with 4 different emissions scenarios. So there's 80 some model outputs that you can choose from to see what the impact would be within our region of climate change in the headwaters. These models are really complex, and I don't have time to go into them in any detail at all. We're happy to answer questions about those if you have them as they arise. But essentially what the modeling approach you're going to take that you're going to learn today, probably some of you are probably already familiar with doing this, but it's called scenario analysis. And the approach is not about running a single model. It's about, if we think about all sorts of different, not only climate scenarios, but management scenarios, policy scenarios, technology change scenarios. If we think about all of those possibilities that could happen in the future, and we run the model under a set of different assumptions, then you can analyze across those assumptions to try to understand the range of plausible futures in this region. And so scenario analysis is really about that. It's not about predicting a specific future, but rather trying to get a sense of how things might change in different directions and what are the drivers of those changes. So today what we're going to do is the hands-on model with the Middle Rio Grande Basin Water Balance Model, which you see on the left. It was developed by Alex Mayer, one of our collaborators here at UTEP and one of his students. And it's a spreadsheet model, but it's a very sophisticated spreadsheet model that handles all of the hydrologic inputs, outputs, recharge, evapotranspiration, return flows, diversions, all of that is in this model. So it's a scientifically validated model. The other model that we have is a hydroeconomic model that was developed by Frank Ward at NMSU. It's a much more complex model, so we won't be working with that today at all. It does all the things Alex's model does, but it also is it handles all of the crop economics. And it's not a simulation model, it's an optimization model, which means it's trying to figure out what would be the optimal choices and features based on an economic perspective. Next slide, please. So what can we do? Well, we have already talked about a little bit of this, but you can work as individuals or as groups. exploring these different future scenarios. We have found that it's pretty hard to get started. It's complicated. There's a lot of choices, a lot of options available. So we've created some what we call canned scenarios for common questions that people like to ask. And so the canned scenarios we've simplified tremendously to make it easy for you to get started, where you pick a question that you are interested in and it'll parameterize all the model inputs for you, and it'll direct you to specific outputs that, that we know are relevant. Once you get there, you can actually look at any of the other outputs that you want to, but we try to simplify it from the beginning. Before I forget, I also want to do a shout out for Jerry, who's online here. He has spent a lot of effort, volunteer effort, documenting these canned scenarios and other things in SWIM for us. So thank you, Jerry, for that. Once you've learned how to do the canned scenarios, you can do customized scenarios that choose any inputs that you would like to look at. We're going to show you how to do that. We don't know whether we'll actually have time to walk you through one of those or not. We'll see how it goes. And you know, this is really about collaboration and collaborative assessment and dialogue about not just plausible futures, but what are the desirable futures? You know, what choices can we make today that will be more likely to generate a future that we all like, as opposed to one that we all dislike? And it's not just about collaboration among scientists, it's about collaboration between scientists and stakeholders, and among stakeholders and with policymakers. That's the ultimate goal of the SWIM project, is to provide a mechanism to have those kinds of dialogues. And so with that, we'll go to the next slide. So I'm not going to talk about this slide in any detail because this is the canned scenario that you're going to be looking at and running. But the general overall process or workflow is that you select scenarios that you're interested in. In this case, we're going to select some climate scenarios. Then you run the model and then you view the results. So at a high level, it's a really pretty simple workflow. The devil is in the details on this. The results are all going to come out looking at automatically constructed graphs. So a lot of them will look like the one on the top that says scenario details. When you see those kinds of graphs, the x-axis along the bottom is always time, and it's usually going to show you 2020 to 2100. And those are annual time steps. We could do it on a monthly basis, but that would be a lot more computationally intensive and not necessarily meaningful for what we're trying to do. And then that y-axis is always going to be some kind of value. So in this case, we're looking at stream flow, and the line that's going up and down, the orange dashed line, is what the model is simulating as stream flow out to 2100. Now, I want to point out that any individual year is not useful because it's a simulation model and there's a lot of year-to-year variability. But you're looking more for patterns. In this particular case, the pattern might be that, well, stream flow is variable, but at least in some years it's pretty good in the early years. But by the end of the century, it becomes very much lower. The two solid lines that you see at the bottom are what we call benchmarks. We found that it was really hard for users to interpret is this a good graph or a bad graph? Are these good results or bad results? So we put what we call benchmarks in there. In this case, those two straight lines are showing you an average of flow over the past decades. So we're comparing future flows to what we've had in the past. And so that's how you interpret that. There will always be a legend at the top that tells you what those different colors mean. The other kind of graph you'll be looking at is what we call an output summary. It's based on that graph we just looked at the top, but what it does is it summarizes it. It just looks at what was the state at the beginning and what was the state at the end. And then the lower right, that particular output is again time on the x-axis. In this case, we're looking at a cumulative graph where we're looking at the cumulative change in aquifer storage according at different aquifers, and also looking at aquifer recharge. So in that case, it's a straight line. It doesn't always have to be completely straight, but since it's a cumulative number, it tends to be more linear than what you see in the other graphs. Next slide. So I'll turn it over to Luis, who's going to help you with the hands-on.
Okay, hi everyone. So what we're going to do now is basically give a walkthrough of some of the basic functionality of the platform. We're going to be putting the links on the chat. I think they're there right now. So feel free to follow me along, or if you want to wait until I'm done with the demo, I'm basically going to do exactly what's on these tutorials where we're putting the links. So let me just change my screen share here very quickly so that I can move on to the website. Hang on here. Okay, so let's begin. So what I'm going to do today is that we're going to walk through this tutorial that we have online, which is called Take a First Splash. So if you're on the home page, you can click on here, and this is basically the tutorial that we're going to be following and going through. So I'm obviously going to be going with a little bit more detail on this demo because I can talk more, and we have a bit more time. I'll probably take around 25 minutes or so, but I'm going to go through all of these steps, which is basically going through what's called a CAN scenario, and we'll go through what that actually means. So before we start actually interacting with SWIM, first we need to take a look at the privacy and policy agreements of their website. So if we look at the top left section of the website, we have this pop-up here, which with information regarding our cookie agreement. So just so to let everyone know why we're using cookies, basically we are using data that we store temporarily on everyone's browsers, so that we can manage your user accounts, so that the interface can connect to our data services. And that way, basically, we don't have any other random websites or bots going into our data. So that's kind of the main reason why this happens. Another thing that we're going to be tracking on the interactions is that any model output that people look at, we keep tracking on what they're looking at and what type of stakeholder you are. So we will see on the tutorials that you will be asked, for example, hey, I'm a water manager or I'm a farmer and so on. So all of this information gets fed into the system as part of what we call a recommender system that eventually we keep on training so that the results that the models give out are more relevant to what that person is his role actually. So if you want to learn more about our policy agreement, there's a link here to learn more. If we click here, this will open up a new tab. We can deny this for now, no problem, in case you want to look at more information about what type of information we're collecting. Other than that, I'm going to go back here. We're going to click on the pink allow button, and basically this will give us access to all of the functionality of the platform. And if we don't click allow, you'll probably see something like this, like a lock in case you didn't allow it. But in my case, I allowed it before, so I can see everything. Okay. So starting from the home section, we're gonna go through the functionality of the CAN scenarios. So if we go to the main navigation bar, we will be clicking on CAN scenarios. And what this section is basically a whole bunch of different topics and questions that we try to answer with a specific model. I don't know if Joe, you want to say a little bit more about the CAN scenarios?
Yeah, Deanna explained a little bit about why we would have CAN scenarios. I just want to say that I would recommend you read through the titles of the CAN scenarios and the questions of interest in the CAN scenarios, because I think it's a good place to start understanding our analysis of the water system. And I would say that while we really actually set up SWIM to encourage users to do their own exploration, to choose their own climate scenarios, to choose their own policy choices, and so forth, to pick the variables they're interested in, That's going to be a lot more comprehensible once you've seen a few CAN scenarios that are interesting to you run, and then you'll be able to actually be empowered to do more with your own choices in swim.
Okay. So before I move on to the CAN scenario that we're going to be looking at, just to mention that the website is both in English and Spanish. So if your default browser is in Spanish, it will load in Spanish. Otherwise, there's the flags on the top left. So if I click on the Spanish one, everything on the site will be in Spanish. And most of the functionality, the variable names, the models themselves, the pictures, we try to make as much possible of it in both languages. So I'm just going to go back to the English version and back to the CAN scenarios here and move on. So the one that we're going to look at for this demo, we're going to scroll all the way down. And what we're going to look at is a scenario of what happens with climate effects down the line, which means through the future, when we're using water conjunctively from both surface water and groundwater. So we're mainly going to be focusing on how climate, it's not really a direct effect on the aquifers, but it does cause an indirect effect on the aquifer because of the use of them. And also the complex interactions between the surface system. So in this case, we're going to be following the aquifers that we have for this region of El Paso del Norte, which is the Hueco Bolson and the Mesilla aquifer. So we're going to be running an extreme stress climate scenario and see how it behaves over our aquifers on the long run. I don't know if there's any questions up to this point that we might want to take care of. Just for everyone to catch up.
Let me comment quickly about this this scenario. We chose one that really shows the power of a integrated model, because groundwater is not something that's directly fed by the annual snowpack melt. So what this CAN scenario does is it traces the logic from the climate through the snowpack, the melt, the amount in the river, the uses in the river, diversions, farms, urban, and then when the river is insufficient for these various uses, which at this point is basically always, and especially if the climate scenario has a river drought, then that water to some extent, which we model, gets pumped out of the groundwater. That's conjunctive water use. Many of you will know this. But what this CAN scenario shows is the way the entire thing sort of propagates from that climate start to the gradual depletion of the freshwater component of the groundwater, and it shows the power of integrated thinking. Okay?
Yep, I think Jerry has raised his hand. You can unmute yourself.
I did. Professor Heyman, what climate scenario would you say we're in right now? This is going to be, the model's going to be an extreme stress. It kind of feels like that now, but what would you say we're in now, sir?
Yeah, well, I'm not a climatologist. I don't necessarily want to be on the record, but I think that when we have tried to just understand things ourselves, for example, Alex Mayer and I have used the moderately dry scenarios. Okay. So I think it's not it's scientifically not the best choice to deviate out to the very edges. You can play with the wet scenario, you can play with the extreme dry scenario, but I think a good choice is to have a long-term persistent dry scenario and see what that effect is. I mean, let me put it this way. It's not in this region that we're actually going to have less precipitation. Well, I don't think we can say that in the climate scenarios. We're going to have a river drought because of warming up in the snowpack in southern Colorado, and in addition, increased heat in this region. We know that the climate will increase the heat in this region, which is going to have the effect of increasing water demand, increasing evapotranspiration, and so forth. So I think, making your assumptions on the dry side is a likely choice.
Thank you, Joe. Okay, so I'm gonna move on through our little exercise here, and we'll continue answering some of the questions as I move along and make pauses along the way. Okay, so we have these two scenarios here at the bottom. We can select any of the two, it doesn't matter. We just wanted to also show kind of the Spanish description of it, but it's basically the same one. Okay, so once we click on view scenario, this is a pre-executed scenario. So this scenario has already been done before. And as you can see, the execution time was actually, date was actually on February 16. So we're looking at something that was pre-made, but I'm gonna go through how to actually customize one as well. So before I move on into looking at the results, I just want to make sure that we know where this CAN scenario comes from. So like we said before, this comes from a dry stress climate scenario. So before I move on there, the process to go through creating your own scenario is a three-step process, very simple, which is select scenarios, we run the model, and then we view the results. But since this is a CAN scenario, we get taken straight to the view results screen because we're not actually customizing our own scenario. But we do have access to actually go to that section, to the select scenarios. And here we can see some of the climate scenarios that we have available for this specific model. So like we said before, we have two models on the interface, which are under our model section. So we're using the water balance model version 2.0, which still has a very few predefined scenarios. But if you move to the other models, there's a whole bunch more of combinations that people can play with. So as we can see, the one that we have selected for this CAN scenario is the extreme stress climate scenario. And if we want to actually look at what is affected as an input to the model, we have this learn more box, which actually shows what's going to be the main input, the main driver for the projection going forward. So as we can see here, the extreme climate stress scenario is really what it's affecting here on this model. It's actually the stream flow that's going to be passing through the San Marcial gauge and goes into the main reservoir, which is Elephant Butte. So if we were to click on a different scenario, for example, a wet climate scenario, so this would be a projection where we can actually see that the inflows are way above the mean values that we have historically. So this is something that people can play with and see how the system behaves on the long run, that maybe a wet scenario will not necessarily mean that we're going to get saved, but who knows, right? Okay, so let's go back to looking at the results of the CAN scenario now. And if I have enough time at the end, I can walk through on how to actually customize our own scenario. And just a quick throwback, we also have some options here at the top right. We have the area map. So the one that we showed on the slide is available here. It's interactive. You can look at where the aquifers are and so on. And this opens up in a new tab. We also have the input catalog, which is basically all of the inputs that go into the model are available here. The data is available here. And this is just the data that the model actually uses. So this data is already curated so that it can be used on the model. Okay, let's go back to the view results section. And let's get an overview of this. So the view results step has two subsections available. It has the result summary, which is the one that we're looking at right now, which gives you kind of the overall results of the whole projection. And it also has an output catalog where we can actually browse output by output or compare different outputs side by side to get a glimpse of the time series and the projection that happened for this specific model. And this workflow works the same for all of the models that are available in the system. So we really actually try to create a generic interface that we can apply to any kind of model, and even if it's programmed on a completely different language. So the plan is to really make a generic interface for it. So going back to the summary, just going through it, we can see that we have the name of the scenario that we're doing, the description of it, some information of this execution. It does start the projection with historical data, which starts from 1950. And then from 2020 onward, it starts the projection of, up to the future. Then we have a bunch of widgets that gives us the overall picture of what happened in the simulation. We have our start year storage. So at the very first year, we were at 15% of storage capacity for this specific CAN scenario. But but we have the option to change that value as well if we want to do another execution. Now the average storage throughout the whole simulation, it was at 27% of the capacity of the reservoir. And by the end year storage, by 2099 of the simulation is going to be at 9%. And that's the projection for this specific example. Now, if we go down, we have some bar charts as well, which basically show the overall behavior on the aquifers. So here we can easily see that the comparison between the Hueco Bolson and the Mesilla intermediate aquifer, this is the cumulative loss, but we can see how the depletion is much higher than the recharge on both aquifers, even though it's not as pronounced on the Mesilla aquifer, and obviously it has its scientific reason to be so that way. And we can also see that the Hueco Bolson, the depletion is much higher values in comparison to the Mesilla aquifer. So I want to make a small pause here to see if there's any questions that we should address. I think we addressed the question, and for everyone to catch up as well. Let me just go to some of the questions before I move on. So Saul was saying about the data that we have here. Like I said before, the data that we have here is already pre-processed for these models, but you can go in and download the data and play with it. And normally we have the provenance of where that data came from. Sometimes it comes from USGS or from some other websites. And we do try to include that link on the interface as well. So I can show you that later on. Let's see what else we have here.
If you want to check Randy Hansen's question, the questions above have been responded. He asked did you do any QA/QC of the skill of these scenarios by comparing against a physically based model such as the USGS RGTIHM model or the climate change projections developed by the USBR that also use the RGTIM, or to see if you have comparable skill, time, and magnitude of change of flows?
Right. Well, I can answer this, and Joe can.
Yeah, go ahead, Luis. Go ahead.
Yeah. So the models that we have, like we said before, they're not spatially explicit, but we do validate them against historical time steps, right? So, for example, from 1950 up to 2015, we validate that the observed data kind of correlates against the simulated data. And that's the way that these models are calibrated. And then they're projected to the future depending on the different inputs or projections that we want to apply on the region. And that's, at least for the water balance model, the main drivers will be data from climate models from the Bureau of Reclamation. So we just select some of the ones that are kind of more representative. Like we said, we divided between dry and wet year, but obviously they have a bunch of simulations, hundreds of simulations. So we just select a few of them so that we can make them available in the interface and people can play with them. But on the full spec of the models, we do run all of the set of different climate scenarios and compare the overall results. So that part is kind of for the publication side.
I should also add that we do, for 2 areas across the basin, we have spatially explicit SWOT models, and we have cross-compared and cross-validated with those in those regions.
Yeah, I just want to say that actually the climate models we're using are from the Bureau of Reclamation. They are those models. The work that Dave Gutzler did, particularly with his student Nolan Townsend, was to make a reasonable estimate of the inflow at San Marcial by taking the Bureau of Reclamation's product, which is a naturalized flow. So it removes the effect of all the use upstream, and went back to statistically estimate how much in a given climate scenario would actually arrive at the gauge at San Marcial. So we're consistent with the Bureau of Reclamation models because we're using them.
Yep. Okay, so I'm going to move on now, and we'll have a discussion section at the end so that we can keep on addressing these questions. Okay, so now if we want to look at a more detailed view of what happened throughout the simulation, we can click on this book icon, and we basically get an output catalog for some of the outputs of the model. Like I said, since we are looking at a canned scenario, we don't get the complete range of outputs that come from the model. Since here we're just focusing on what happened on the surface storage and the groundwater, the system is just going to show output values that are representative of that question that we wanted to answer with this canned scenario. So just to give the example of looking at the time series, we can filter our different outputs by categories. We can also use the search bar. So in our case, I'm going to show the losses and the recharge that we showed on the slide. So if I look here for WECO, for example, I can select the WECO cumulative loss. I look for Mesilla. Here's the Mesilla one. And if I click on all, this shows the ones that I have selected. Now, once I selected the output variables that I'm interested in looking at, you'll see that the buttons here below the search bar are enabled now. So we have a set of functionalities that we can use here in SWIM to look at that information. And the one that I'm going to be focused on is just a look in the detailed view of these outputs, which is through view selected. So I'm just pausing a little bit so everyone catches up in case they're doing it on their own. And I'm going to click on view selected now. Right. So now we have a detailed view of those specific outputs that I want to look at. So you can see that we can look at side by side the output that I selected, but I can add more, and they keep on adding to the screen. So that we can look at them side by side and scroll through them. So each of the output boxes contains, okay, this is the name of the output that we're looking at. It gives us a better description of what that output is about. This is the variable name that the model actually uses in the code, just in case we want to know that. The category it is, and the default units that are going to be represented on the charts. Now we have different ways of visualizing the data. So the plan here in SWIM is to add different ways of looking at the information so that we can give a better interpretation of the results. So the ones that we have available for these two outputs, we can look at it as a line plot. We can look at it as a bar plot, or we can just straight look at the table. Here we have the time series of the table of the results. And if we want to analyze this further on our own computer, we have the option to click on the export button, and this saves the file as a CSV that we can open in Excel and look at the data there. And I'll get back to this one because we can do more stuff with this as well. So just going back to the line plot, since we're talking about a loss, we have some tools so that we can interact a little bit more with the visualizations. So maybe it will make more sense to reverse the y-axis of this visualization. So if I click on reverse plot, we can visualize this better and say, okay, we're looking at a loss, so we want to see the aquifer go down, right? So that's just an example. And then if we keep on scrolling down, we make available a bunch of data tools so that we can keep on adding to the plots. So it gives us more tools to better get interpretation of what's going on. So this really doesn't give us the whole story, right? So we can do a bunch of changes. Like we said, we're really focused as well on having different measuring units available so that we have both the metric system and the English system available on the system. So if I click on millions of cubic meters, And now we can see that the y-axis has everything in millions of cubic meters, and it's the same for our table now as well. Another important thing is that this data plot might not be enough to actually come to any good conclusions. Okay, we know that it's okay, we have cumulative loss, yes, it's going down, but what else can we say about this? So one of the suggestions that we have through all of the different stakeholder meetings is, okay, I want to append data, I want to add more data into this plot, which we can do. So as long as the other data sets of our outputs use the same unit system, we can append them to this very same piece of information. So right now we're looking at the Weckable sun, so we can append the recharge to it. So now we can also see the recharge. So now we know that the depletion is a lot more pronounced than the recharge. So we can already say something about this. And then, okay, well, now I want to compare it against the other aquifer, the one that we have on the right, but I want to look at it on the same chart. So we can do that as well. We can go in here, select the other two outputs, and now we can compare what happened on a yearly time step on both aquifers. So this gives us a lot more information to get a better conclusion and interpretation of the results. And again, we can look at this in different plots. Here's the bar plot. And the table also fills out automatically. So if you want to export this data straight to Excel, now you have the time series for all of these 4 outputs of the system. So yeah, so that this pretty much kind of concludes the first splash tutorial of the CAN scenarios in the platform. And I don't know how we are on time. Maybe I can quickly show how to customize your own scenario.
Yes, we're good, Luis.
Okay, so
You can pause for any other questions. I don't see anything in the chat, but you will still have 15 minutes.
I have a, well, Joe kind of responded in the email, I mean, in the chat, but if you want to expand on this, Enrique Prunes asked that now that you have the swim model up and running, which is a great work, by the way, what are the next steps to use it or promote the use of it to test climate scenarios and evaluate potential strategies or management options to improve the water management in the system, including reducing groundwater overexploitation and restoring water flows in the river? And there was a reference already uploaded there in the chat of Alex Meyer and others' work on the game simulation that they prepared. But if you want to elaborate on this.
Joe, do you want to, or you want me to?
Well, yeah, I mean, I put up that one effort that we did with the serious games. And I think actually today is a great opportunity. And we've done other events like this, but it's a great opportunity to ask you all who are in the audience to come up with any sorts of ideas you have about how to make better use now that we have this platform that we think is usable and accessible. How can we make good use of it? That's part of the purpose of today's presentation.
Mm-hmm.
Yeah, we have run stakeholder workshops, small ones, and we are intending to continue to run stakeholder workshops. So if any of you are interested in being parts of that, then there's a slide at the end where we are recruiting for those. We also have several proposals out that include funds to bring people in to do stakeholder workshops. Kat, who's also online here, has done 4 virtual workshops. So we know with it being binational, it's difficult to show up in person. So the virtual workshops are helpful, but we will also be doing face-to-face workshops.
I also want to just throw out something that's even maybe another step further, but the computer architecture for this platform is available. Part of what actually took a lot of effort was getting it to be in open source coding rather than just using off-the-shelf products like Excel that are controlled. And but the point of that is if there's somebody out there who wants to undertake the heavy lift of developing regional models for other places, other regions in either country or across transboundary regions, you know, we would be excited to have somebody take advantage of that. Obviously, it's a lot of work to do the model for a specific region and to calibrate all the data. But, you know, if you find it exciting, go for it. We want people to use it.
Yeah, and just to piggyback on Joe, so the infrastructure of the system, it's made standard to some programming languages. So if anyone's doing models on Python, on Scilab, or on GAMS, the platform, I mean, the services on the platform are ready so that it can handle models that are made with those languages or pieces of software, right? They will need to follow a certain standard on how to code the model, but all of the infrastructure is ready, and I think by mid-year we'll be making all of the code and the application and the interface itself open source, and everything will be completely available online. And we're also making a huge effort so that all of the different modules of the system are available to easily deploy on a server by doing minimum configuration as possible, which is also kind of one of our targets there. So I think since we have around 10 minutes left for the demo, I can quickly show how to customize your own scenario, which is the most interesting part, and that's where people can really have fun at and play around with the inputs and the different scenarios. Because the CAN scenarios are questions that came about from different workshops. People wanted to answer from the model, so we made them readily available, and it's a good way to get started and get introduced into the platform. And then from there, we can move on to actually doing our own stuff and our custom stuff with the models that are available. We still have the limitation of what the models can do, but still we can play around with them. So if we're in the CAN scenario view, we can directly go here and start customizing our own scenario if we wanted to. So we just go back into the workflow to the select scenario step. And here we can say, okay, I don't want to look at the extreme stress. I want to know what happens on the wet, what happens to the aquifers on the wet climate scenario. Does it get better? Does it get worse? Do they recover or not? What happens there, right? So I can just click here on the wet climate scenario. So it's selected. It's the data on the backend is already loaded and ready to go. And this is the data that's going to be loaded into the simulation. That's going to be projected on forward and see what happens on the aquifers and the reservoir storage. Now, if we wanted to get really picky, we can go to the input catalog and say, I want to go directly to each of the values and modify them with the data that I have. Like, I don't want to be dependent on the predefined data that Swim has, right? So we can go here in the input catalog. I can look for the inflows at San Marcial. And here are the numbers that are going to be going into the simulation. But let's say I want my start year or the inflows to be different. So I can, but I work in different units or something like that. Well, I can change that too. So for now, I'm just going to change this value to 100 CFS, I think, yes, cubic feet per second. And it shows me the line plot as well. So the value that I changed is there already. So this, by doing this dynamically, you're starting to change the inputs of your scenario. And once we go back and go back again, it's not going to be reflected on the view results yet until we actually run the model again. So we can click here on run model, or we can click on the green button. So I'll click on the green button. Then I have to keep my scenario name. This is going to be my own custom scenario now. So scenario, wet sample, right? And then here it's going to ask me what type of stakeholder I am. So this is very important so that the system starts capturing what you're interacting with and what you're most interested in looking at. So let's say I'm a water manager, for example. And then on the scenario description, once I click on it, this auto-populates. So if I already had selected a scenario, a predefined scenario, it's the wet climate scenario. But since I change an output, I say, okay, the first year is 100 CFS and 1950, something like that, right? And here you have just this check mark where you can click on agree, which is basically the the policy agreement that we do tracking of the outputs that you're going to be looking at. And then we submit. And we have an error. So let me go and run the water balance instead. These things happen. Okay, let's run this one. And run this again. Submit. Okay, let's see this one. Buys. Okay, there it is. Okay, so now once we manage to run one of the simulations, well, you get a lot more data in comparison to the CAN scenario. So as you can see, we have different values. This one, we're using the first version of the water balance model. So the projection starts in 2020. And so it starts at 27%. The average storage was better. So you can see that the results already changed on the wet climate scenario. And even the end year storage at the reservoir is at 88%. But still there is depletion going on in the aquifers. And here we have more detailed stuff on what happens on the different sections of the aquifers. We have the mesilla, and this gives us what happened on the agricultural side, the urban side, the overall recharge, and the overall loss. So running a complete scenario gives us a lot more information. Then if we go to the output catalog, we have here, we can see that there's a bunch more of model outputs available to play with, right? So we can say, hey, I want to look at what happened at the reservoir, which is below Elephant Butte, and the one that controls the releases downstream. We can click on that one. We can view the data selected for that one, and this will be the Caballo releases, right? And you can see that we have these flat sections here. So this simulation actually complies with the operating agreement from 2008 that kind of tells us how much water is to be released from the reservoirs. So it does have its ranges, and by applying those rules, this is the results that we get, right? And again, we can append more information into it, and this one has a lot more options because we can also append input data sets, right? So maybe we want to look at the observed values. So I think this is actual data. If I click on it, oh no, this is not the right one. The inflows, yeah. So we can compare against what were the inflows at the San Marcial, right? We can append output data sets as well. We can look at the reservoir storage. We can look at the evaporation. So we can already start playing with a lot of information and making the information more complex. Go back here. So another thing that's relevant to the recommender system is that the system always tries to get some feedback. So since I selected that I was a water manager, maybe as a water manager, I say, okay, the Caballo releases are super important to me. This is very relevant, submits, and this gets send us feedback into the system. And what the recommender does is that the order in which things are displayed here, for example, on the catalog, depend on that recommendation system. So as the system learns, it puts on top the ones that might be more relevant to that specific type of user. But if we were a farmer, for example, or a city resident, maybe we can expect that this order of results will be different for them. And now just to finish up on the last few minutes, we have another cool feature, which is called cross compare. So once we played around with different simulations and so on, what if we want to compare across simulations, across a simulation that we did before? And that's what cross compare does. So we can select one of the outputs. Let's look at the storage, for example, the storage at Elephant Butte. We can click here on cross compare. And what cross compare does is that it loads scenarios that have been executed before. So these are public scenarios that are available already on the system. And I can compare that against another one. So let's say I'm going to compare this wet scenario against one that says normal conditions. But there's a bunch more scenarios available. So these are scenarios that other people have executed and that are available on the system and that have been made public, right? And so we can compare against any of this. So I click compare, and here it is. So we have on the left-hand side what happened on the wet climate scenario, and on the right-hand side, we have a scenario where we have a bit more normal conditions, right? So the normal conditions, you can see that the situation is a bit more grim, and the one that we were looking at on the wet scenario, it's a bit more optimistic, but we still have a lot of up and downs in the projections. And yeah, I think that pretty much covers some of the main aspects of the system. So I'm going to stop this share and go back to the slides.
Do you have time for a quick question?
Sure.
No, what Randy Hansen, what feedbacks are used between groundwater and surface water flows in the swimming models? Do you also allow changes in land use or agriculture?
Yes. So so it depends on which model you use, right? So the first two models just focus on the in and outs of the water system, and this kind of gives us a perspective on how it's used. So this one is fairly basic. And the one that we have about agriculture, it brings a lot more stuff. We have the diagram here. So this one does consider what happens like on the crop level, if we change the prices on the crops, if we focus on certain crop groups. So it depends on which model you're using, the kind of things that you can play with.
And another question, is there an option to upload other hydrographs to the model to compare with the results from model scenarios? Thinking here on uploading estimated naturalized flows and environmental flows, then we could compare how each scenario benefits.
Okay. Yeah.
Or
So
not desired states of the river.
yeah. So we don't have the option to upload your own data yet. The data that's on the system is the one that is used by default on the models, and you can change it, of course. But it would be a cool feature to consider, right? So that people can upload their own data and compare against what's coming out from the models.
Models never stop developing, right?
It never stops. There's always a huge list of requirements, but we have to be careful, right? And kind of give priority to the ones that are used the most, the ones that are really meaningful to the people that are using it.
Luis, there's a question about downloading the results. Can you show that again?
Yeah, sure. Okay, so let's say that you already ran a scenario, but you left the screen. The scenarios are available to look at them at any time. So if I go to public scenarios, these are the executions that have been complete. We can see that some of you have already been playing around with this. For example, the one that I just did, probably, I think it was the wet climate scenario. Well, so we can click on the outputs. So this is going to load the screen again of what we were looking at, but I'm going to change the perspective here. Okay, so here are the results. So to download the results, right now you still need to download the results one output at a time, but we're working on the option to export everything in one go. So for example, this button that says export, this one downloads the whole catalog into an Excel file, and you can look at the list of all of the outputs that are available for this specific model scenario. But to download the data, for example, I'm going to click, well, any of these would work. You select it. We will need to go to our table view. And on our table view, we can see the data for the time series. And there's an export button, and this one exports the data to Excel, right? So right now it's still on a per output basis, but you can basically run the same process for also the input data. So if you only want to actually use input data for your own models, and that might be useful for you, which happens a lot maybe on the hydroeconomic model, because this one has a lot more data into it. So let's say we want to look at something about crops. We have some average production costs here, right? So here's a table that you can download, for example, right? So for example, these are the average production crops for each of the different irrigation districts. So this might be interesting information that you want to play with on your own models, and that could be useful for you. So you can go to the table view and export the data, and you have it available. Okay, any other question? Okay, I'm going to move on to the slides then. Go back to the slides.
There's another question here quickly.
Yeah.
Since from Holly Browse, since you are collecting data about use of the platform, I am curious to know which kind of stakeholders are using the platform so far, or which stakeholders did you expect to use and are not doing so, or at least so far?
I don't know if you want to take this one, Joe, because you did the
Yeah.
stakeholder
Or probably,
selection.
do you want to go back and just show the roles? I think there was some, as you said, there was some previous work by Joe, and we have the roles that you can see there, and that was based on Joe that he can explain. But we are now at the stage where, you know, we have something running with some errors apparently, with some small errors, but it's ready to be used by a lot of people. So we would really.
The question was about who is using it, and
Yeah,
it's hard to call that because we've been testing. So like I go in there and I claim a role that's not even me. So you know, it's right now the data are kind of artificial. But in our workshops that we've been running, Kat, you want to chime in and talk about the kinds of stakeholders that have been coming to our workshops?
Yeah, so we've had a pretty big demographic of students coming in, some activists. We've had some people working in the management sector. So whether they're managing water here on the border or in New Mexico or in El Paso. And then we do have some scientists, but not as many. So we've been looking at more students, community members, and people who manage water in our workshops.
One thing that I think we did learn or have learned, we really thought there would be farmers would get really involved, but they seem to be more interested in what's happening next year than what's happening 40 years from now. So we have had some farmers use it, and have gotten some interesting feedback from them. But as Kat said, at this point, it's been a lot of community members.
Yeah, Luis, shall we go back to the presentation? So I think we've done some discussion just to keep up on, sorry, but so we would like to hear from you right now. Hopefully some of you have already played around a little bit with Swim online during these 45-50 minutes. These are some of the questions that we want to start this discussion with. We have around 10 minutes for this. We'd like to hear what feature of piece of information got your attention. What did you really like when you were using Swim right now? If you envision doing something with Swim, what do you envision doing with that? And we've heard about some people interested in generating scenarios for their own areas, so maybe we can have more. How would you use Swim to make decisions, if using it at all, right? If this is relevant to your interests, if you're gonna be using Swim again, that would be great to hear as well. But if not, what are the things that would encourage you to use Swim? And any other questions or suggestions? Again, I think this is a great venue to hear from people interested in water futures and see how Swim can align to your interests. So for this, and I know Jerry is raising his hand, please feel free to unmute yourself, raise your hand, or type your question in the chat.
Jerry's hand is up.
Yeah, I've been working with Swim for about a year now. And there was a piece of research that was done by Professors Heyman and Hargrove that was very helpful to me in giving me a context to understand how SWIM overlays the Middle Rio Grande, but particularly the various communities of users. And it was an article they published in April of 2020 during the lockdown in Land, and it's called A Comprehensive Process for Stakeholder Identification and Engagement in Addressing Wicked Water Resources Problems. That is, problems where everything's connected to everything. I had a little education from Luis on that too. I mean, we were talking about just simple things like, well, if you wanted to retain the water in the reservoir to enhance economic activity and recreation, how would that work? Well, you can run that scenario. But again, because it's 110 degrees all summer long, a lot of that water is just going to go up in the air in evaporation. And so it's not going to be useful for agricultural uses. But I would highly recommend this piece of research to you, to give you, at least it gave me a great context for understanding the kinds of questions people ask about agriculture and water when all of these things are interconnected. Thank you.
Thank you, Jerry. And Joe just typed the link to this reference mentioned by Jerry in the chat. Anyone else? What did you like? Are you gonna use SWIM? Thank you. We have a post from chat. Thank you, Kat, reminding us that there are many tutorials, and Jerry helped us to write some of the manuals from, a user perspective, not involving SWIM development, which was really useful. We have the tutorial that you saw, that is the first splash, how to change your scenarios. There is a lot of documentation. There is references like this one to the research behind SWIM, but there are also references for those developers interested in continuing or extending SWIM, more technical documentation to do so. The question is, once you generate a scenario, can you modify the scenario to the other? And yes, you can load again your scenario and continue and do changes to it. And it's optional whether you want to make it public or register in SWIM, so you can make them private as well. And something that's really useful, if you're running your scenario, you want to share it with someone else, you can send the link and other people can see it too.
Yeah, so just to build on top of that, when you run a scenario and you're looking at it again, you can change it. And once you run it again, it becomes a different scenario. And that will be available either on the public section, or if you're a registered user, you can have your own private section of scenarios, so that only the ones that you were executing, you can look at.
And this is part of the value of giving it a name that you will recognize in the future. So you run it, and then you decide you have some further questions or ideas, and you want to come back to it a month later. You can find your scenario and just go right back in there and continue to play with it.
Yeah. There's a question from Randall that's a bit more technical about the feedbacks between groundwater and surface water flows in the SWIM models. So the models that we have in SWIM are aggregate models. It doesn't really have any physical interactions, but the way that we handle the recharge back to the river and so on is kind of just through some placeholder data that we got from different papers and publications, right? And they're the ones that actually run the physical model. So that data comes from work from Shuping Sheng, and we basically get some of those values from there so that we can apply them to the aggregate model.
Yeah, and I think that the place where it is possible to vary crops and land use, though not in a geographically explicit way, is in the hydroeconomic model, because there you can look, you have less water, you start to see some crops drop out of the system, like let's say alfalfa. What is the effect of that, both on the alfalfa, but also on the hydrological variables that follow back through from that? So the hydroeconomic model is definitely more of a challenge to run and to interpret, but it's the place where you can, that has the power to do those sorts of things.
Yeah. So that model takes a bit more time to execute. It's not instantaneous like the one we just saw. It does take a few minutes to run. But yeah, since it's an optimization model, the way that it works is like you can set the values of acreage that you want for a specific type of crop, because we don't have crop per crop. They're arranged in different groups of crops, like for example, veggies, pecans, and the main ones, or forage. And you can assign a portion of acreage to that specific group of crops, and the model will optimize so that it gets the best economic outcome.
And you can optimize it for various uses. Alex and Frank and other people, some of the names are escaping me, but have looked at the economics of providing water for riparian habitats along the river. So you can go into it with a goal of finding out, now, if this is my goal, how much water is it going to take? You know, what is its effect on crops and so forth?
Great. I see some people that are leaving, so thank you, everyone. I just want to tell you what's next for SWIM. During this year, we plan to complete another really, I would say, cool feature that we've been working on for a long time, you know, with the help of all the SWIM team, is generate narrative elements. So if you remember, you can see tables, you can see graphs, but we want to create text and natural language for humans in English and Spanish that will provide context on the output of the models on the baseline. So anyone can understand without the need of having all this technical knowledge what those output mean. So we also plan to make SWIM interoperable with national infrastructure on the US side to further support the exchange and integration of data. That is really important to us, not only making the code available, but all the data that we have and all the models that we have in relevant repositories and other frameworks, specifically for consortiums such as Quasi. That's the first one that we are going to start working with, and HydroShare. So we don't want this to be just an isolated tool. We are following all the best practices and principles to make these available to everyone. We will have other things as knowledge bases, again, not only for the graphical interface, but you can access them and extend SWIM in with not a lot of efforts, right? And something very important that Diana mentioned before, we have been working on having evaluations and stakeholders meetings. And we will share these opportunities to engage with SWIM for a specific evaluation this year through this forum for you to consider participating as we have done it in the past. Through this forum, we have already sent a few invitations. But more importantly, and this is where I want to tell everyone, we are in the process of envisioning where should SWIM go next, right? And pursue our next stage for SWIM. And we'd love to hear from you if your research, and I'm already reading some of them, if your interest overlap with SWIM features, with SWIM capabilities, please contact us. We have our email, swim@utep.edu. And this is not a sport team, as you know, but this is a Water Future group. Maybe you can go to the next one. This phase, this SWIM 2.0 that you are seeing, that it's simpler, that uses a lot of the latest computing techniques and practices, is supported by NSF. Our funding will be until the end of this year with the award 1835 897. And as Joe mentioned at the beginning, the initial work of SWIM and the conception of SWIM was supported by USDA. And we also had resources from the Cyber Center, also supported by NSF. And we really would like to acknowledge the work and contribution of many, many people to get SWIM to where it is right now. Or modelers, or data providers who gave us the model and said, I want to make it available to everyone, right? Current and past students, community volunteers such as Jerry. Some of them, others of you are here in the call. And I also want to thank on behalf of the SWIM team to the Permanent Forum of Binational Waters for the opportunity to share with you our efforts and our tool. I really, really hope you can use it. And thank you for having us. Again, contact us at swim@utep.edu and we will be happy to engage with you. Thank you.
Thank you, Natalia, and all the SWIM team for the opportunity. I mean, this is great stuff, and this is the way to fill up that gap between science and policymaking. It's one of the efforts, the needed efforts to engage the community and develop these tools that are actually accessible to every type of audience. We just need to get there and do our job. So this is very helpful, and I see that you already have interests on using the platform on the Mexico side, on different basins as well. So there's a lot of work to do. I mean, the more work you do, the more work you have, right? In the future. So thank you everyone for assisting. I want to thank our sponsors, California Institute for Water Resources, Arizona Water Resources Research Center, Texas Water Resources Institute, North American Development Bank, and of course UTEP for trusting in the forum and to present to you their efforts. And remember, the forum is for you, for all of us to use it and to expand a little bit our efforts into a more broader spectrum. So with that, thank you everyone for attending. Hope to see you for the next one. Thank you, UTEP and the SWIM team. I'm sure we can keep working on this in the future. And if you have any questions, please contact them, contact us. We will have our videos uploaded in the website. We're going to have a brief document of this presentation as well on the website, available to all of you and to share it with the community. And with that, I'm going to say goodbye. I'm going to say thank you again and see you next time.